Hi, this is Gokul here. Today we are going to discuss about adaptive design pattern. I'll be using an audio player example to explain you the pattern. Uh, as you can see in my slide, I've kept an adapter image here. It supports multiple electrical pins. And similarly, we can use this pattern to adapt multiple functionalities by binding those classes together. Let's go to the theory. So the adapter pattern converts an interface of a class into another interface the client expects, whoever is expecting. This pattern mainly adapts one object to the other one, and adapter lets classes work together that couldn't otherwise because of the incompatible interfaces. And of course, through adaptive design pattern, we can reuse the code a lot without changing it. And of course, the adapter class itself ensure the conversion between those interfaces. To explain the adaptive design pattern, let's take an example. Today we are going to develop a media player application, say VLC here. So the VLC player, what we are developing, knows only how to play the raw audio data. It's not aware of how the decoding happens, because decoding is very specific to the audio format. And you know that nowadays we have a lot of audio formats like MP3, OGG, WAV, MIDI, and so on. And of course, in future also we'll have much more. So when you develop an application, you should not be coupling those features. Otherwise, you may need to rewrite the code and change the design a lot. And that's why we're going to use the adapter pattern to solve this problem. So that VLC knows how to play the audio data, or how to render album art and so on, where other classes will do the decoding for VLC. Yep. So let's take a class diagram of this scenario. You can see here I have a VLC player class which has a function called play, which takes the file name as an argument. And there is another class called VLC encoding interface here that has a pure virtual function called encode, and it has some utility function to play the raw audio data. It knows how to use the VLC player to play some audio data. So that's the purpose of this class. And of course, there are two more classes like OGG decoder to raw audio, MP3 decoder to raw audio, and it has its own operation. So here in the MP3 decoder, you can see I'm sorry, I think I have used wrong operations here, but it should be a decode MP3 file, and it should be here, it should be decode OGG file here. End of the day, the purpose of this class is to encode the file format into the raw data. And here is the main class who connects these various file formats to the VLC player interface. That means the audio decoding adapter will inherit the VLC encoding interface to enable the encode functionality, and it will use the play raw data, and based on the file name it will select the corresponding decoder. So he's the adapter who knows the both ends. Let's go to the program now. So you can see here I have a VLC player. I have declared a VLC player object here, and I'm trying to play various file formats like my music.mp3, OGG. I'm trying to play an unknown format also like OGG, which may be a future audio format. And I'm sorry, I need to add two files here. Yep. So here you can see the VLC player class. So the VLC player class, as I mentioned here in this presentation, it has a play operation. So the play operation creates the adapter, and it just passes the file name to decode or play, and based on the status it will print something and delete the object. That's it. And we have a VLC control interface class here, which is very specific to the VLC player. It is not aware of any decoding. The VLC control interface will use some VLC functionality to play the data. So you can see here, and it has a pure virtual method called decode. Yeah. And we have several file formats under this folder. You can see MP3 decoder, OGG decoder, and so on. Tomorrow we can have one more decoder. That's okay. And the actual decoding operations happen within this function, because MP3 decoding or OGG decoding needs a lot of algorithmic operations. A lot of pseudocodes will come here. That's fine. I'm just trying to put some dummy data here in this function. And the audio adapter VLC. Here we can see a audio decoding adapter for VLC. This is the main adapter class which connects the file formats and the VLC interface. You can see here the audio decoding adapter for VLC has overridden or implemented the decode function, and here comes the main logic. So here I'm just checking whether the file format is MP3, then I'm calling the MP3 decoders decode MP3 file function here. If it's a OGG, I'm using the OGG file format. If something new or unknown comes, I'm not doing anything, I'm returning a false here. And as I said, the VLC interface has a play raw data function. So once the data is encoded, it will try to call the VLC control interface play raw data, because that knows only how to play the raw data. You can see here. So in this example, the particular formats MP3 decoder or the OGG decoder is not at all aware of the VLC or the player behind it. Tomorrow we can write a new player with the same classes. There is a big use of code reusability. And in the meantime, the VLC player or the VLC controller interface is not aware of the audio format which decodes the data. It knows how to play the raw audio data. But here comes the main guy, audio decoding adapter, who knows both, who works as a bridge to connect both. And tomorrow a new interface comes. It's a matter of changing here and adding a new class called some OGG format or something, OGG decoder or something like that. Let's run this now and see. Okay, we can, I'm sorry, yeah. You can see I have tried to play a MP3 file, my music MP3, and file type is MP3. Then I get called here in this MP3 decoder class, and we have encoded the, we have decoded, I think I have used a wrong term here. We have decoded the raw audio from MP3 file format. When it comes to OGG, the adapter will call the OGG decoder, and I'm just giving some random name here like .voc. Then the adapter will check whether it has a decoder support. If not, it says, hey, I don't know how to play this file. We can just quickly add support for this OGG class. Let's write, maybe we can add here in this OGG decoder itself, or add new class, say VOC decoder. I'm just adding it, and I don't need this C++ file. I'm just removing it. Yes. So the VOC decoder's responsibility will be just to decode the VOC format into the raw audio. Let's copy and paste the same from the OC decoder. I'll just rename it as OC decoder to raw audio, decode OC file, and I'm saying decoded raw data from VOC file format, and I'm just adding inheritance here, public OC decoder raw audio. Then I'm just checking whether the file format is VOC. Then I'm calling decode. I think I have VOC file. Yeah, decode the VOC file. Easy. Then I need to of course add the include formats OC decoder. Let's build it. Now we can see, yeah, there is no error because now our new format started supporting the player. The beauty here is that I haven't touched the VLC player or VLC control interface to add support for this particular format, but rather I enabled this format in the adapter. So here the client is VLC and it's not worried about the new format came into picture. That's all about an adaptive design pattern. Thank you very much. Bye.